Alright, so today, our lesson is lesson 7.4. We are comparing linear versus nonlinear. Can anyone tell me, what do they think the difference is between linear and nonlinear? Ricky?
Straight line and non-straight line.
Exactly. That's mainly what we are trying to figure out today. Are we going to have a linear line which is straight or nonlinear? Even if you look at our labels that we put in your notebook, notice how linear we use straight line font. Nonlinear, this was Miss Majors, was pretty smart. She used kind of the curvy one because nonlinear are not going to be our straight lines. So let me just change. Alright, so the first ones we're going to focus on, we have 3 groups that we're going to look at and put together. The first group is, how can you tell if a graph is linear or nonlinear? We are focusing on a graph. So, these 8 pictures are the ones that you want to get out in front of you. Okay, I want a couple people, all you're going to do is come up and you touch it like that, and then you can drag it to where it goes. So, can I get a couple people to come up and sort? Where do they feel they go? Then we'll discuss. Tyler, Alejandra, Braden, Rick, and Cohen, Michael. One person at a time, though.
No.
Oh, you failed it. There you go.
What's mine?
No. There you go. All right. Ricky. Touch it. Now touch the. Yep.
It's curved.
Your head's in the way. Hey, I didn't know. You picked the easiest one. I know. I'm doing the hardest one.
That's not even the hardest one.
Shut up, I know. Oh.
Touch it. Now do.
Oh yeah, I did the hardest one. Yeah.
You want a freaking metal?
Also, I'm good.
Yeah.
Okay. Let's look at what we have so far. So, zoomed in. Come on, forward. Alright. Nah, getting off topic. Let's stay in place. Our first ones. You will put these down once we confirm them. But, the very first one, yards to feet, this one is linear. We know it's linear. It's a straight line. Has a slope. It passes my vertical line test. If I look vertically, it will pass that. It's only going to mark on one place. Cohen chose, he said, the hardest one.
Yeah.
It was
Good answer.
That's
It
not
is
true.
non-linear.
I
Observe sucker.
But, why? It's close. I mean, this is one that's typically missed.
Oh.
Because what? That's 2 points. The line is linear, where I have one straight line. But when we have 2, it's going to be crossing at a place. We will not count it because it's having 2. It's changing my rate. So it cannot be just our straight line. We need to have one straight line. We'll see. If you're interrupted, never. Okay. Yards to square yards. This is nonlinear. It's really close to being a straight line, but there's a little bit of a curve. This is kind of like our exponential growth that we work on. You'll do it when you get to algebra, where you'll see that it's starting to change. This happens when we're talking about squaring numbers. These two are definitely nonlinear because they're curving. The bottom one here makes like a little wavy line. It goes up and then down, then up. That is also nonlinear because it's not a straight line. It's curved lines. How about this one? This is one that people kind of argue and do not know for sure. We have a vertical line. Would this vertical line count as a linear line or nonlinear? Nonlinear. Awesome, because if we use the vertical line test, it's going to hit every single one of those points. y equals 3 on this one. Even though a vertical line is a straight line, vertical lines do not count as linear lines. Biggest reason is our linear lines, when we're looking at linear functions, if these are our linear functions, is because, oops, I don't use a highlighter. Remember how that very first day we said to be the function, x can only go to one output. Well, here, x, this equation is x equals 3. It's a vertical line. This is x equals 3. That means when x is 3, y is 0. When x is...
I need Rylan Willis to the office, please.
Yes, ma'am.
Thank you.
When x is 3, y can be 0. When x is 3, y can be 2. X is 3, y can be 7. X is 3, y can be negative 15. With a vertical line, our input output, my input has multiple outputs, which means it is not a function. Come fill out this pass and you have to go through the order also. Okay, I think we have one more for graphs. There's pests. Last one. Ooh, I don't know what I hit. But I did something. Straight line. Come on. See, I hit something. Okay, last one. That one is a straight line. It's a very small, it's a light line that goes negative slope, but it is a linear line. So, when we look at a graph today in your homework, one set of your homework, they're going to give you a picture of a graph, and you're going to have to say if it's linear or non-linear. It has to be straight. One line and not vertical. That's the important thing. A straight line, not vertical, and one line. Okay, the next one we are going to look at. You need to get your photos. You should have glued those ones in.
Wait, are we doing the other ones? Okay.
Yeah.
We need more glue. Yeah, we need more.
We got a couple more glues.
Can I have a good one?
You got the shirt. I'll give you more, but you
I
just
got
have the shirt.
a
Ricky, turn around, please. Rated. Folks, sit up here. Okay, the next one. How can we tell if a table, this is the one that I think is the most difficult, or it actually requires the most work. Okay? There's 3 main ways we could identify on a table. 1, we can look for a constant rate. So one thing I can do, no, it'll stay on the same one. It's just on my thing. That's so we can do a constant rate. Yeah, that's why you're going to overlap them. And our constant rate means it needs to be adding or subtracting. I'll sit up here. If I look at this first one, I'm going to look at my inputs and see how they are changing. Well, this one, 0, 2, I added 2. This is adding 1, and this one's adding 2. Okay. What I'm going to do though is I want to find where my x was the same one. So I'm going to get rid of I'm not going to look at the one that's +1 because that's not following the same rate. Make sure you're following this because you will have this one on your homework and quiz. So looking at the table, I'm going to notice that x went up by 2, x went up by 2. So I'm going to look at the corresponding y output. From 1 to 11, it went up 10. Now here's how I did this. Since x went up by 2 between 3 and 5, this one has better matchup adding by 10. 17 to 26, though, is
Who's on a streak?
so 10 is adding on one of them, the other one's adding 9. Are they constant? Is it the same? No. Because of that, this will not be a linear line. It's going to be very close because 10 to 9 is a very small difference, but it will be nonlinear. So, if you work on something else, stop so you can make sure you understand this because it is complicated understanding it. I'm going to say it again how we did this. You take, I'm going to zoom in on this. I'll start all fresh because I want to make sure we do this right on today's assignment. Showing you the easiest way to do this. So, you look at your input-output table. And I'm going to look at my x and say, x went up by 2. 0 to 2, I increased by 2. I need another point that does the same thing between my x's. Remember, x can be my input. I can choose any numbers I want. So when they did 3, 2 to 3 was only up 1, so I'm not going to use that because it's not the same constant rate. But from 3 to 5, that is the constant rate. So the first thing I do is look at my x and find at least 2 points that have the same constant rate. From 0 to 2, I added 2, 3 to 5, I added 2. And remember, we have to be adding or subtracting. If it becomes multiplication, that's not going to be a consistent rate when we graph it. I go to the y then. Because I used this point and this one, I will then look at these two. So from 1 to 11, that rate increases 10. Once again, on the x, since I used 3 to 5, I will look at the 17 to 26. That increase is 9. Because the increase is not constant and the same, we know it's not a linear line. It's going to be very close, but it's going to be one that will probably, instead of a straight line, it will be one that's probably curving just a little bit. So, we erase all of this now. We'll put this one under non-linear. We'll zoom out. It's the one that goes 0, 1, 2, 11, 3, 17, 5, 26. If we do the same thing here, actually I want to use this one. If you get the table that says 13, 7, 15, 10, 17, 13, 19, 16, let's compare that one. I look at my x. This one from 13 to 15 went up 2. From 15 to 17, it went up 2. 17 to 19, it went up 2. This one's pretty simple. My x is staying constant, going up by 2. So now I can compare my y. 7 to 10 is adding 3. 10 to 13 is adding 3. 13 to 16 is adding 3. Because that is the same. Because we're adding 3, it's consistent. That means my line will be straight. It's a consistent slope going up. So we would mark this as a linear line. Let me erase this so I can move it over. You're still pulling these and you're just gluing them over.
I don't got this.
You can use the purple still too. You can use the purple underneath as well, guys. On your foldable, it's the green and purple. Okay,
I got the same question.
what about this one?
Or you put there you go.
Okay, this one is going to be different. This one, if I look, 2 to 6 is a difference of 4, 6 to 14 is 8. I don't have that constant rate on my x. So I have to look for a different method. The other method I could do is if I have the same slope. If I look at this new one, remember to do slope, slope is y2 minus y1 over x2 minus x1. The way we check this in a table is we have to choose 2 sets of points. So I'm going to use this and this. So I'm going to find the slope between these 2 points. This is x1, y1, x2, y2, because that's the order they came in left to right. So this would be y2. I'd say 10 minus 5, 6 minus 2. And I found that my slope was 5/4. That should be easy. You actually did that yesterday. You took a table and you found the slope. Yesterday we gave you all linear functions on your tables. Now what I'm going to do is now I'm going to take these 2 and find the slope between those 2 points. If the slope is the same, I have a linear function because it's going to be the same slope. It's going up straight line. If they are different, then it's not a linear line. So to do this one, I'd have 20 is now my y2 minus 10. 14 minus 6. And we get 10 over 8. Can that simplify? Yeah, how do I simplify 10 eighths? Divide by 2 and we get 5 over 4. Our 2 slopes are the same. Make sure you go in there. Playing for blue screen. Since I have the same slope, I would have to put it in a linear line. Okay, I'm going to erase all this. Okay. The next one. Okay, put the scissors away. You're done. Okay, next one. X is 1, Y is 1. X is 2, Y is 2. X is 4, Y is 4, or 16. 8 is X, and Y is 64. When we solve this one, we could check for the same slope again. So I could do slope. I could look to see if there's a constant rate. Or the third way is, could I write the function down? So I could. Someone in my last class, they identified it. Can anyone tell what the function is? What is the rule? How is x related to y? It's times it by itself, right?
Oh,
So x is times it by itself. This equation, this is actually going to lead into our next little part. But my equation, my output is my input squared. 1 times 1 is 1. 2 times 2 is 4. 4 times 4 is 16. 8 times 8 is 64. Now, do you feel like this will be a linear equation or nonlinear? This will be non-linear. What? The reason why is we are squaring our input. That means it will not stay constant. And I'm going to show you a way that we can check it for today's assignment. But this is going to be non-linear. Okay, we are almost out of time, but almost out of time. The last section we're going to look at is an equation. And this one, Ricky, let's turn and focus on this messing. Okay, the last one is with equations. With equations, this one I feel is simple. We have to be able to simplify them so they can be written as y equals mx plus b in slope-intercept form. So, looking at this one for sure, y equals 2/5 x. Yeah, my slope is 2/5. And I have x. You can set that email. Laptop's over here. So that one is for sure my slope-intercept. This one is definitely one. This one will be a horizontal line. It's that special line. Y equals 4.7. So every time you go up 4.7, it's fine. My little fine. And it's going to be a horizontal line. This one, I'm going to, because of time-wise, it will be 5y equals 2x. Because if I divide by 5, and I'm solving this equation, yeah, we get y equals 2/5 x. Now, the last few. Can anyone tell me why on these three, look it up here, because we're almost out of time. Why are these three not linear functions? Cohen? What's wrong with them? Okay, but we don't have to have a y-intercept. A y-intercept could be 0. Why is it a problem when this is squared? Yeah, we cannot square our slope. We can't put our x. So if you look at an equation and it's written with x squared, it's nonlinear. We cannot divide by our x. Our x cannot be the denominator. The last one, this one, when I simplify it, 5xy equals 2, it will come out with the x to the denominator. This one, I'm just going to put over here for your timing. We could solve that equation. I'd minus x, and it'd be y equals 3x plus 5. Now, here's what I explained before the bell rings. We have 2 minutes, so I need you to listen carefully. Your homework is going to be 7.4 in the foldable. 7.4. But listen to this, because this is important. You're going to have a couple that you have to look at the graph and say if it's linear or non-linear. Michael just have a seat, bud. You have a couple where you have to see the table. Go back to our notes if you need to about how did we do the table. The last one with the equations. Here's the giant help. You can go to Desmos. If you type in the equation, I'm going to show you the one that did not work. Oh, why do I have people talking? Listening up. Y equals 1 minus x squared. 1 minus x squared. That is where we get this. Brayden, please focus. We're almost done. That is where we get this equation. If I did y equals 4 divided by x, that's where we get this equation. So, once again, your homework, 7.4, linear, nonlinear for the two tables, linear, nonlinear for the three equations, and the two graphs. You just have to glue them in.